Up YouTube, Mr. King coming at you live from the studio. Here are the questions for the day. Please pause the video and answer them now. And remember, protons are positive. The P is for positive, and electrons are negative. So if something has more protons than electrons, it'll be positive. If something has more electrons, it'll be negative. I just want you to remember that when you are doing Tuesday's assignment. So Tuesday is called making ions. So what you're going to want to do is pull in the slides here. The first slide is some background. The main thing is, remember, elements' goal is to have a complete orbital. They can do that two ways. They can either gain electrons to get a complete orbital, or they can lose electrons to get a complete orbital. And that's what we're going to be looking at today. Remember, the first two, though, are an exception because they only have 2 valence electrons. Everything else is trying to either go back down to 2 or get up to 8. Okay, so remember, all these elements, they want to lose electrons so they can go down to this column. All of these elements, though, they all want to gain electrons so they can get up to 8, so they can all get their full valence electron. Here is the first part. First step is you need to draw a dot diagram for beryllium using the periodic table. So to do that, remember you need to go to the periodic table, find Be. Be is right here, and it's in the column with 2 valence electrons. So you put 2 valence electrons on Be to show that it has 2. But then, now you need to figure out, is it closer to 0 or is it closer to 8? If it's closer to 0, beryllium will lose 2 electrons and go back down to its last orbital. So beryllium lost 2 electrons because the reason is because it's closer to 0. It's easier for beryllium to lose electrons. So when it loses electrons are negative. So if you lose negative things, you'll be positive. For example, all elements, just like people, they all want a complete circle. People want friends, though. And sometimes not all friends are good. Some friends are toxic and have negative energy, just like these valence electrons. So if an element loses toxic friends, if it cuts them out of their life, it'll actually be more positive because it doesn't have that negativity in its life anymore. So it's just like elements, you lose 2 valence electrons, you'll be more positive because you're losing negative things. The other example we'll do is phosphorus. So phosphorus, if you look for it on the table, you'll see phosphorus is in this column. And this column all has 5 valence electrons. So you put 5 valence electrons over here. Okay, so it has 5 valence electrons. And then you have to figure out, is 5 closer to 8 or is it closer to 0? 5 is closer to 8, so it's going to gain electrons until it becomes 8, just like this slide. So phosphorus should now have 8 valence electrons because it wants to have a complete circle of friends, complete circle of valence electrons. But phosphorus was a little bit too desperate for friends, so it gained 3 toxic friends. It gained 3 electrons to be complete, but those electrons are negative. Remember, they're negative, just like friends can be negative energy. So, since it gained 3 electrons to become complete, it's going to be -3 or 3 minus because it gained 3 negative things. Okay? So here's a way you can remember it. So, for example, beryllium is a positive ion. It has 2 plus, whereas phosphorus is an anion. It has a negative charge. And the way to remember if it's a cation or an anion, cats are positive. So cations are like a positive. Cations are positive. That's what you can remember. So when you're doing these problems, here's what you should do, what you should be thinking. Okay? You count the valence electrons here. So fluorine has 1, 2, 3, 4, 5, 6. Fluorine has 7 valence electrons. So 7 is close to 8. Since 7 is close to 8, you're going to round up and grab 8 electrons. And make sure that fluorine has 8 electrons. So keep dragging them over until you have 8 electrons on fluorine. And do them in pairs and have 2 on every side. Okay. It doesn't look perfect. They should be in 2s, but it should have 8 electrons. Okay? Whereas potassium is the opposite. Potassium is closer to 0. So potassium is going to lose its electrons. So you don't need to add any, but you should know the charge. So fluorine has 8 valence electrons. So it gained something negative. So since it gained something negative, it gained 1 electron. So it gained 1 toxic friend. So it's -1. So it's an anion. Potassium's the opposite. Potassium is closer to 0, so it's going to lose an electron. And since it lost a toxic friend, it's going to be +1. Aluminum, 3 is closer to 0. So 3 is going to go down. Aluminum's going to go down to 0. And since it lost 3 toxic friends, it's going to be +3. And both aluminum and potassium are cations. So just to summarize, first step, figure out the valence electrons, count them. If it's closer to 8, add valence electrons until it's 8. And then for every electron you add, you get a minus because electrons are negative. If it's closer to 0, you will take those electrons away. And then you figure out the charge. For every electron that you lose, you get a plus. And cations are positive, anions are negative. That's how you do the rest of these problems. Thank you so much, everyone, for sticking with me. Have a great day.